NEC 126.F.1.A encompasses a broader range of equipment than just distribution-type equipment. It extends to include transformers, uninterruptible power supplies, which are commonly known as UPS, and UPS battery cabinets. The key principle behind this section of the National Electrical Code is that it applies to equipment not specifically addressed elsewhere in the code. To understand its application fully, we need to consider the nature of transformers, UPSs, and UPS battery cabinets within electrical systems. Transformers are fundamental components in electrical power distribution. Their primary function is to step up or step down voltage levels to match the requirements of different equipment and systems. They are used in a wide variety of applications, from high-voltage transmission lines to low-voltage power supplies for electronic devices. UPSs, on the other hand, serve a different but equally important role. They provide backup power in the event of a power outage, ensuring that critical equipment continues to operate without interruption. This is particularly important in applications where downtime can have serious consequences, such as hospitals, data centers, and industrial control systems. UPS battery cabinets are an integral part of UPS systems, housing the batteries that store the energy used to provide backup power. The batteries are typically lead-acid or lithium-ion, and they must be properly maintained to ensure reliable operation. Now let's consider the specific wording of NEC 126.F.1.A and how it relates to these types of equipment. The section likely addresses safety requirements for electrical equipment that is not explicitly covered in other parts of the code. This means that if a transformer, UPS, or UPS battery cabinet is not subject to specific requirements elsewhere in the NEC, it would fall under the purview of 126.F.1.A. This is significant because it ensures that all electrical equipment is subject to some level of safety regulation, even if it is not specifically mentioned in other sections of the code. The requirements in 126.F.1.A may address a variety of safety concerns, such as overcurrent protection, grounding, wiring methods, and equipment labeling. The specific requirements will depend on the nature of the equipment and the potential hazards it presents. For example, transformers may be subject to requirements for overcurrent protection to prevent overheating and fire. UPS may be subject to requirements for battery ventilation and spill containment to prevent the release of hazardous materials. UPS battery cabinets may be subject to requirements for battery disconnects and overcharge protection to prevent battery damage and fires. To determine whether a particular piece of equipment falls under the scope of 126.F.1.A, it is necessary to consult the NEC and review the specific requirements for that type of equipment. If the equipment is not specifically mentioned elsewhere in the code, it is likely that 126.F.1 applies. It is also important to note that the NEC is updated on a regular basis, so it is always necessary to consult the latest version of the code to ensure compliance. Understanding the scope of NEC 126.F.1.A is crucial for electrical designers, installers, and inspectors. It ensures that all electrical equipment is installed and maintained in a safe manner, reducing the risk of electrical shock, fire, and other hazards. Firstly, let's delve deeper into transformers and their relevance to NEC 126.F.1.A. Transformers, being essential components in power distribution, aren't always explicitly detailed in every NEC section. The NEC often provides general guidelines for transformer installations, but specific scenarios or unique transformer types might not be directly addressed. This is where 126.F.1.A becomes relevant. If a transformer installation doesn't neatly fit into other NEC categories, this section provides a framework for ensuring its safety and compliance. Secondly, concerning UPS and UPS battery cabinets, their inclusion under NEC 126.F.1.A stems from their specialized function and potential hazards. UPS systems designed to provide uninterrupted power involve batteries, inverters, and charging circuits. These components introduce specific safety considerations that might not be fully covered in general electrical equipment sections. For example, battery outgassing, thermal management, and proper disconnect mechanisms are crucial for safe UPS operation. Similarly, UPS battery cabinets housing multiple batteries require adherence to specific ventilation, spill containment, and overcurrent protection standards. Since these aspects might not be exhaustively detailed elsewhere in the NEC 126.F.1.A acts as a supplementary guideline. Thirdly, when interpreting NEC 126.F.1.A, it's vital to consider the not specifically listed criterion. This means that if another NEC section directly addresses a particular transformer type, UPS configuration, or battery cabinet design, that section takes precedence. However, if there's ambiguity or a lack of specific guidance, 126.F.1.A fills the gap. For instance, if a specific type of transformer with unique cooling requirements isn't explicitly covered elsewhere, 126.F.1.A would apply, prompting a thorough evaluation of its safety features. Fourthly, code compliance with NEC 126.F.1.A involves a multifaceted approach. It's not merely about checking boxes, but rather a comprehensive assessment of the equipment's design, installation, and operational characteristics. This includes verifying proper grounding, overcurrent protection, wiring methods, and labeling. Furthermore, it entails evaluating the equipment's suitability for its intended environment, considering factors like temperature, humidity, and potential exposure to corrosive substances. Fifthly, when dealing with transformers, UPSs, and UPS battery cabinets under NEC 126.F.1.A, documentation is paramount. Manufacturers' specifications, testing reports, and installation manuals provide valuable insights into the equipment's safety features and compliance standards. These documents serve as evidence of conformity and facilitate inspections by electrical authorities. Sixthly, the application of NEC 126.F.1.A often necessitates engineering judgment. The code provides a framework, but the interpretation and implementation require a deep understanding of electrical principles and safety practices. Electrical engineers and qualified installers play a crucial role in assessing the equipment's suitability and ensuring its safe operation. Seventhly, it is important to note that the NEC is not a design manual. It provides minimum safety standards, but it's the responsibility of the designer to ensure that the electrical system meets the specific requirements of the application. This may involve exceeding the minimum requirements of the NEC to ensure optimal performance and reliability. Eighthly, consider the implications of using older equipment. If an older transformer, UPS, or UPS battery cabinet is being reused or repurposed, it's essential to ensure that it meets current NEC standards. This may require retrofitting the equipment with new safety features or replacing it altogether. Ninthly, special attention should be paid to the location of the equipment. The NEC has specific requirements for the location of electrical equipment, such as clearances, ventilation, and protection from physical damage. These requirements are designed to minimize the risk of electrical hazards. Tenthly, the NEC also addresses the issue of arc flash hazards. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. It can cause serious burns and other injuries. The NEC requires that electrical equipment be labeled with information about the arc flash hazard, such as the arc flash boundary and the personal protective equipment required. Finally, the continuous evolution of technology necessitates ongoing education and adaptation. Electrical equipment is constantly evolving, with new features and functionalities being introduced regularly. Staying abreast of these advancements and their implications for code compliance is essential for electrical professionals. This includes attending training courses, participating in industry events, and staying informed about updates to the NEC and other relevant standards. The NEC is a comprehensive document, and it is essential to have a thorough understanding of its provisions to ensure the safe installation and operation of electrical equipment. In summary, NEC 126.F.1.A serves as a safety net encompassing electrical equipment not explicitly detailed elsewhere in the code. This includes transformers, UPSs, and UPS battery cabinets, provided they aren't subject to specific requirements in other NEC sections. Compliance requires a comprehensive assessment of the equipment's design, installation, and operational characteristics supported by documentation and engineering judgment. Furthermore, ongoing education and adaptation are crucial to keep pace with technological advancements and evolving safety standards. To further clarify the scope, consider typical scenarios. A small control transformer used within equipment might not have its installation spelled out in other articles, bringing it under 126.F.1.A. A modular UPS system with unique battery configurations may need to adhere to this section if specific battery installation requirements aren't explicitly stated elsewhere. The key takeaway is to first check if other articles cover the specific installation and equipment type. Only then does 126.F.1.A become the governing section. It's always best to consult with a qualified electrical inspector or engineer to ensure compliance with the NEC. The goal is to ensure that all electrical installations are safe and meet the minimum requirements of the NEC. This includes transformers, UPSs, UPS battery cabinets, and any other type of electrical equipment. Remember, safety is always the top priority. By following the NEC and consulting with qualified professionals, you can help to ensure that your electrical installations are safe and reliable. This commitment to safety not only protects lives and property, but also contributes to a more sustainable and resilient electrical infrastructure. Remember to always refer to the latest edition of the National Electrical Code for the most up-to-date information and requirements. The information provided here is for general guidance only and should not be considered a substitute for professional advice. It is always best to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards.